Ask My Instructor 4.4.31. A cable runs along the wall from C to P at a cost of $3 per meter and straight from P to M at a cost of $5 per meter. Let X be the distance from A to P. If M is 8 meters from the nearest point A on the wall where P lies, and A is 18 meters from C, find X such that the cost of installing the cable is minimized, and find this cost. If X is the distance from P to A, then the length of cable needed to run from C to P along the wall is 18 minus X. And the length of cable needed to run from P to M is the square root of 16 plus 64. The cost of running the cable from C to P is $3 per meter times 18 minus X meters. The cost of running the cable from P to M is $5 per meter times the square root of X squared plus 64 meters. So the total cost of installing the cable is the cost of the cable from C to P plus the cost of the cable from P to M. Or f of x equals 54 minus 3x plus 5 times the square root of x squared plus 64. Our goal is to minimize the cost function. To do that, we first find f prime. Once we have f prime, we ask two questions. Is there any place where f prime does not exist? The answer to that is no. F prime exists everywhere, so our function is differentiable everywhere. The second question we ask is, where does f prime equal 0? We set f prime equal to 0 and solve for x. Setting f prime equal to 0, we get this equation. Add 3 to both sides, and then let's square both sides. The square of 5x is 25x squared. The square of a square root is just what's inside, and then the square of 3 is 9. Next, multiply both sides by x squared plus 64. And this is what we get. Now, what we're trying to do is we're trying to solve for x. To do that, we first isolate x squared. So isolating x squared, I have 25x squared minus 9x squared, and then I have 9 equals 9 times 64, or 576. Divide both sides by 16, and then solving for x, I get x equals plus or minus 6. Since x is cable length, we choose the positive value of x and ignore the negative value. So x equals 6 meters is the critical value for f of x. It's a critical point. Notice that for the cost function, the values of x that are allowed come from the closed interval from 0 to 18. So the values of x can be anything from 0, including 0, all the way to 18. Now that's a closed interval. So by the extreme value theorem, to find the maximum and minimum, we need only evaluate the function for the endpoints and the critical points. Once we do that, we find the smallest for our min and the largest for our max. So let's evaluate at x equals 0. When x equals 0, it means we're running the cable all the way from C to A and then out of the wall from A to M. And when that occurs, the cost is $94. For our critical point, x equals 6, that means that I go 2/3 of the way from C to A, and then I do a diagonal from that location to M. And the cost of that is $86. And then my other end point, if x equals 18, that means that it doesn't run along the wall at all. It just goes directly from C to M. And in that case, that's our most expensive scenario, and that's about $98.50. So looking at the two endpoints and the critical point, we're looking for our minimum value, and our minimum value is 86, which occurs when x equals 6 meters. So the least expensive scenario would be x being 6 meters, so I'm running the cable along the wall for 12 meters and then cutting across the room to the location M. So and then that will cost $86. Take care. Have a nice day.